Good afternoon. Yesterday we started talking about limit involved infinite. So on the board we have a question of let's find out the limit when x goes to negative infinity. What do we mean by negative infinity? You can consider the number line. If x goes to infinity, that's the far left of the number line. If x goes to the positive infinity, that's far right of the number line. If x approaching a single number, that's a finite location on the number line. So this notation is indicating x should be a really large negative number. If you want to numerically calculate the limit, you can try x equals negative 1,000, x equals negative 10,000, just to say what this number could be. So for example, you can pull out your calculator. So if you were to calculate the limit numerically, this. In your calculation, you will apply a x value that is said to follow the direction of the limit change. Right, so it's approaching negative infinity. So we try, if you want to numerically calculate, you have to try some number that is close, maybe not exactly equal to the limit, but at least it is close. So then your calculation will be 5 over 5 minus 3 over 1,000 square. Okay, I see what that gave you. Roll your calculator, make sure the order of operation is correct. So,
I feel like 0.99999.
and what do you get?
I made it. It's like a really small number. It's like 0.9.
Yeah.
So probably equal to 1. Probably.
Okay.
For our answer.
So your answer is very close to 1.
Yeah. You make it by negative million. It just shows up as 1.
This is a square, so if you square a negative number, it actually becomes positive. So it shouldn't be slightly bigger than one?
Yeah.
Right, so we can roughly figure out the limit. It doesn't equal to any of them exactly, but we'll give you a pretty good idea what the number is supposed to be. That's how you can numerically calculate it. You can also graphically figure out the limit. Like we mentioned, you can figure out the limit, use numbers, use graphs, or you have to analyze the change relation. So we graph this. Y is equal to 5 over 5 minus is 3. Over x squared. I have confirmed 2 over x squared. So that's how it looks like. You can see there are quite a few changes in the middle, but that doesn't really concern us because the question asks me for the limit when x goes to negative infinity, right? I hope you can understand. So maybe the function is really complex. There's a vertical asymptote. There are a lot of changes here. But the thing is, we want to know x is approaching negative infinity, and that y value is a concern, right? So that y value right here is this. Yeah? So that's the height. That's the y. That was the limit that we're looking for. So that's another way to look at it. Whenever the question is asking x goes to negative infinity, that's the left side behavior of the graph. If x goes to positive infinity, that's the right side behavior. If x goes to one single number, you don't have to look at the number on the x-axis or reach to the graph to find the y value, which will be the value. All right, so this is how we find it graphically. We can also determine the limit. Just look at analytically what is going on. And that is the part that's more difficult than numerically or graphically because so what do? We look at what this x causes change. So x is approaching a negative infinity, and then you can see we have x squared, so that is the immediate implication there. If x goes to infinity, what happens to x squared? X is a really large negative number. If you square a negative large number, that's going to be even bigger, right? If you square a negative 1,000, it becomes positive 1 million. X squared goes to infinity, and then we have 3 over x squared. So 3 is divided by a really large number. When we see x squared goes to infinity, we mean x squared is really large. So 3 is being divided by a large number. You divide a finite number by a super large number. This number actually goes to, well, this number is
0 positive.
Right. So it will be approaching 0 from the positive side. And then we have 5 minus this number. Since 3 over x squared is approaching pretty much 0, so this is like approaching 5 minus 0. That would just be 5. So the entire denominator is actually approaching 5. And then back to the overall change, 5 over this number 5 is now approaching 5 over 5. Okay, the denominator approaches 5, numerator is equal to 5, so that is actually 1. So that's how you can gradually say how this number is affecting this, and they're affecting this, and affecting the whole thing. So analytically, if you analyze the changes between the independent variable and the dependent variable formula, you see that it is approaching the number 1 as well. So analytically, numerically, that's roughly 1 if you put in the calculator, or you can use a graph. On the graph on the far left of the picture of the function, it is also. I want to use one example to show that how we handle when the question limit calculation involves infinity. I'll always try numbers when things are not clear. I can use number always before possible value. Ricardo, that was not the right one. It was one. Remember
Oh,
5
okay.
over 5? 5 divided by 5. This one approaches 0, so I have everybody. Okay, that should be today's attendance. This is one. Do you have any more questions you want to talk about? We would have finished 1, 2, 3, 4 so far. Questions? Right. Yesterday we started talking about limit involving infinity, so we're gonna try to look at the first few questions. 6. In class, I did most of the 1.5. If you still have any confusion running this example, feel free to ask about it. So I'm hoping that right after we talk about social section, you can start working on the assignment as soon as possible so you can see some of the questions are similar to what we're doing in class. If some of them are different, then we should catch them as soon as possible, so making it really, because the longer we wait, the harder it is to understand it or relate it to the current material. Right, so this is question number 1 on homework 1.6. It says this question has 2 parts. The second part doesn't show up once you finish the first part. I don't see this kind of arrangement as often.
Oh, I wonder, I did the first part. It's different.
Yeah, there's something else pops up. So it says, what is the vertical asymptote of the function? Vertical asymptote is like an invisible line that separates your graph into pieces. So if you draw the picture of that, you can easily see the vertical asymptote. But if you want to go by analytically, let's analyze the denominator. So see. More spaces. So you see the function involve division. If the denominator is equal to 0, we would have computation issue. So we would want the denominator to be 0. So you're going to set the denominator x squared minus 49 equal to 0. Right, those are the x value that will cause us a problem for the computation, and they'll behave like the invisible law or the number that x is forbidden to take on. So you can see x squared equal to 49, then so x equal to 7, right? We take square root of both sides of the equation, x equal to 7 because 7 squared is 49, or negative 7, x equal to negative 7 square of negative number also equal to negative 7 squared also equal to 49. So there's actually 2 solutions. And not only as a rule, all polynomial of a degree 2 have 2 roots. So it's only it only makes sense if you're able to find 2 numbers. Sometimes these 2 might be the same. For example, x squared equals 0, then x equals 0. Does that mean there's only 1 root? It means that x equals 0 is multiplicity of 2. So kind of 0, 0, the 2 roots equal to each other. So that's the vertical asymptote that we find out, because x equal to 7 make the function undefined. So x equal to 7 is like this vertical line that separates the graph into 2 parts. X equal to negative 7 as well. So these are the kind of number that we don't want x to take, because if x equal to these 2 numbers, the function would have no value. So x equal to any other number but these 2. And so this is going to be the vertical asymptote. So we'll put in negative 7, 7. Right, once you submit it, then You see, there are a few other questions for the calculation. Let's start asking for the right-hand limit or left-hand limit. Since we got asymptotes, they were supposed to be negative infinity or positive infinity, but we don't know which one it is until we analyze the behavior of the function around 7. So we're going to try to analyze the behavior. If you want to graph it, you can quickly know are they going up or are they going down. If it's going down, it's negative infinity. If it's going up, it's positive infinity. They're either positive or negative right now. Okay. Okay. So we're gonna look at this one, right? So we have x is approaching -7 from the negative side. You can also use the number to see how it is. Like you can do if it's less than -7, which is like -7.1, which is on the left of -7. We use a number, plug in x equals -7.1, see what it is. But I can try to use the calculation. So if x is approaching, just theoretically, if x is approaching -7 on the negative side, then x squared, so slowly, x squared would be approaching, see, x is approaching -7. So x squared definitely approaching -7 squared, which is 49. Are we okay so far? I'm trying to little by little do calculations. So x squared becomes 49. All right. So then what happened to the -4x squared, which is a numerator? It will be approaching -4 times 49, right? Because x squared itself is approaching 49. It is actually approaching 49 from the positive side, because -7 is to the left of -7, so its absolute value is higher than 49, right? So it's bigger than 49 actually. From the positive side, just look at mark out the direction. Now the denominator is x squared minus 49. So this is approaching. So you see what happened here. The x squared is slightly bigger than 49. This is approaching 7 from the negative side, right? You got -7. If it's more negative, you got -7.1, right? That's x, right? -7.1 and -7.1. So the square of that -7, the square x actually is slightly bigger than 49. So this is actually 49 minus 49, which is approaching 0, right? X squared is 49, so x squared minus 49 is 49 minus 49. That's actually 0, right? But approaching 0 from the positive side. So this is approaching 0 from the positive side. But what we're going to do is division. So we are trying to make the numerator approaching the -4 times 49, whatever. That was a finite number. But the numerator is approaching 0. So what happens to the entire fraction? The whole fraction is going to approach like -4x squared over x squared minus 49 will be approaching. See, the numerator is -4 times 49. The denominator is approaching 0 from the positive side. So we have a negative number divided by a positive number. So the entire thing is a negative number. But because this negative number has a denominator equal 0, this is actually negative infinity. That makes sense? So this is negative. Right. So that was the first one. Then moving on to this one, you see I'm not writing it down, we decided to change the differences. If x is approaching -7 from the positive side, it will be on the right of -7. If it's on the right of -7, it will be like -6.9. So it will be bigger than -7, but it's a negative. So the absolute value of x will be smaller than -7, right? Smaller than 7. So x squared will be approaching 49, but it's approaching 49 will be smaller than 49. So this is less than 49 by a little bit. So x squared minus 49 actually approaching 0 from the negative side. And therefore, the numerator is a negative number, denominator is a negative number, the whole division approaching a positive number, but it's still going to be a positive infinity. And that is that part. I hope that makes sense. The rest of it, this positive 7 is easier because if you're approaching 7, so here this is 7. If you're approaching 7 from the negative side, you're less than 7. If it's less than 7, then x squared minus 49, this is less than 49. So smaller than 49 minus 49. It is approaching 0, but it's approaching 0. The denominator is approaching 0 from the negative side. And numerator is negative 4 times this is approaching 49. So numerator is negative 4 times 49. Denominator is approaching 0 from the negative side. The entire thing is positive. So this is a positive infinity. All right. For the same reason, this is approaching 7 from the positive side, which is bigger than 7 slightly. So then the x squared minus 49 is slightly bigger than 49 minus 49. So this is a positive 0 in the denominator. So the denominator is positive, a positive small number in the denominator, but it's a negative number in the numerator for sure. And therefore, the whole thing is negative divided by positive, which is negative. So that's negative infinity. All four, because this is the asymptote, all four are supposed to be infinity, but we have to carefully consider, is it a positive infinity or is it negative infinity? So I'm going to answer the question. So here we're going to answer, I believe it was I and F to represent infinity. So here is negative I and F, and this is positive infinity.
It's just I.
Huh?
It's just capital I.
Oh, it was just I. Okay, thank you, thank you. That's should read the question more carefully. The I, so you can also look at the graph. It's definitely quicker, but having the ability to do both would be a lot more beneficial. Negative 4x squared. This denominator numerator is x squared minus 49. So you can see it's negative infinity on the left of negative 7. On the right side is positive infinity, and then positive infinity, and then negative infinity. So if you see the picture, you can see that it's negative infinity, positive infinity, negative infinity. So that way, that's without analysis. All right. Of course, there's another way, which is just trying the number, because all you care is the positive and negative. You know they're all infinity. What you can do is to plug in numbers. So that one you can plug in x equals negative 7.1. Calculate the whole thing. You see that was a negative number, so you know that's negative infinity. This one you can plug in a 7.1. It's positive 7.1. Negative side. So you should do 6.9. So use 6.9 for x and then calculate the whole thing to see if it's positive or negative. If it's positive, you know that was positive infinity. Because you know there was like infinity anyway, you only care about the sign, like positive sign or negative sign. And use any number to test out, you determine the sign. That's the first question. There's definitely multiple ways to determine this. The more practice question that you do, the more likely you can kind of understand the pattern. All right, try number 2. We're trying to look at this for the calculation. Most of them do not involve like highly intensive mathematical part, more of the understanding of it. I know graphing will probably provide a very quick solution to it, but that also means that you know how to read the graph. And sometimes we're a little bit not confident about the graphing, and then we don't get to do the graphing on the test. So I guess it's better we try to do it without computerized graph. All right, let's look at the question number 2. The first one is when x is approaching 0. If x is approaching 0, that means the denominator equals 0. This whole thing is like 1 divided by that x is approaching 0, so x squared is pushing 0 from the positive side because x squared is guaranteed to be positive, so you have a positive 0. But not positive 0, positive small number. I'm writing that because its value is approaching 0, but it doesn't equal to 0. So that's right, more or less a limit notation. And x is approaching 0, so this is really 7. 0 plus 7 is 7. So the first example, you have a finite numerator, but you have a denominator. 7 times 0 is still 0. Any finite number multiplied by 0 is so the denominator approaching 0 from the positive side. So as a consequence, this is a positive infinity. And second question, we see that 2 over, I would have to specifically understand the 5. X is approaching 5 from the negative side. So x minus 5 is 5 minus 5, which is approaching 0 also from the negative side. So x minus 5 itself is approaching 0 from the negative side. If you cube this, all right, and you cube a negative number cubed will still be a negative number. So as a result, the numerator is still 2, it's constant. The denominator is approaching 0 from the negative side. So find the number divided by 0 normally approach infinity because it's a negative in the denominator. So this is actually a negative infinity. Any questions so far? All right, so this is my way to write shorthand to have the calculation quicker. The one below the question 3, x is approaching 3 from the negative side. So x minus 3 is approaching 3 minus 3 is approaching 0 from the negative side. So we have a 2 divided by a small number that is a small negative number. So 2 is divided by a super small negative number. Therefore, the whole thing is reaching negative infinity. This one, x is approaching 3 from the positive side. Then x minus 3 would be approaching 0 from the positive side. So this is a 2 divided by a positive small, arbitrary small number. The whole thing has a positive infinity. So then that's analyzing each of them. By the changes in the variable, you identify the changes in the function. So feel free to graph them to say if the answer are correct. So we have this, I guess we write infinity, use infinity. Okay, that's infinity for the first one. That's all for question 2. We can graph to get a understanding of it. For example, the first one is 1 over x squared times x plus 7. Right? Yeah. So we want to know the limit value at 0. Right? You can see that when you zoom in, the behavior around 0 is infinity. There's positive infinity for the first one. I look at it on the graph. This is x minus 5 cubed. Second question, we have 2 over x minus 5, which is cubed. Oh. So that's how it looks like. You can see to the left of 5, it would be 2. This is a 5. To the left of 5 is going down. That's negative infinity. To the right is positive infinity. So left or right at the 5. 5 is the asymptote right there. Okay. I'll stop there. Any questions so far? Infinity, and these are all virtual asymptotes because you can see the virtual line is when x equals 5. That was a virtual line that separated graph into two different pieces. Note that whenever you have a virtual asymptote, the virtual asymptote is separating the whole graph into separate parts, and they will never cross by. All right, if you have horizontal asymptote, sometimes the curve will cross a horizontal asymptote because horizontal asymptote is the behavior at the far right. Right in the middle, they might actually cross the horizontal. It doesn't, it's approaching the infinity part, but it doesn't affect the middle. But virtual asymptote is really a x value that the function is forbidden to take on. So therefore, you don't see anything here. Because if the function were here, then that's not asymptote anymore, right? So the graph, a function graph never cross a vertical asymptote. It might cross a horizontal asymptote, but it never cross a vertical asymptote.
So how you do the plug-in method again, it's not working for me.
Which one?
Like when you plug in a number, so like if x is approaching 5 from the left, you just plug into the equation like 4.9.
Yes.
And then if it gives you a positive, then it should be positive infinity, right?
Right. Yeah, so this is approaching 5 from the negative side. We would do 4.9 to go 2 over 4.9 minus 5 cubed. And 4.9 minus 5 is negative 0.1. So negative 0.1 cubed of the numerator is 2. Right, so this is going to be 2 over, that's just negative 0.001. So the answer is negative 2,000. That kind of means that this is a negative. To be putting in the calculator, what it wouldn't work out.
No.
Let me see if you put in the calculator. You would 2 over, for instance, 2 over 4.9 minus 5, for instance, to the power. It's negative 2,000. Yeah, it gives you, depend on the number that you try. Sometimes it's super large, sometimes it's not as large. You might have to try another one to see the difference.
One's not a one-sided limit.
Which one?
It looks like the second one,
Uh-huh.
but two-sided. There's no plus or minus.
Let's see, you have a different type question. Yeah, I think it's because the 6 power, because doesn't matter x approach 5 from either side, because the power is 6, the denominator is guaranteed to be positive. So the numerator is positive, denominator for the power 6, the denominator is guaranteed to be positive. So it's positive, it's positive infinity no matter what.
Because I was thinking it might be the power six, but
Right, if it's an odd power, like power 3, the two-sided limit, it will be the, but if it's one-sided limit, it would be like negative 3 or positive 3. But if it's power 6, it goes to the side.
because it's an even power.
Yeah, even power will have the number.
So, so if it's a, you can't recite it limit, it's always
Positive, yes,
Okay.
for the power. Any other questions? Mine have the odd power, that's why the denominator ends in the negative sign. But if it's a power 4, after the horsepower, the whole thing is positive. And that would be a positive. Any other questions? This is number 2. Let's see other questions. This is question number 3, and we'll look at how it works out. Can you guys try this question yourself and then we can see if we agree? Try it yourself. You can use number, if you're more of a number person, try numbers, see if it works out. This is 9/2 at the limit, so we can try and see what 9/2 is. You tend to use number 9/2 is 4.5. So for example, the first number is approaching 4.5 on the positive side. We can try x equal to 4.6 for the question 1. And we can try 4.4 for the second question. That way we can see what it is. We know that 9.2 is the issue here because 9 minus 2 times 9/2 will cause the denominator equal to 0. So we know for sure these two limits, they're supposed to be infinity. So all you have to figure out is, do we get positive infinity or do we get negative infinity? So using number, you might be able to see whether it's positive or negative. And that's the reason that we can try number. So identify the limit. And for example, the first one will calculate, 33 times 4.6 divided by 9 minus 2 times 4.6.
Why are you using 4.6?
Because it's a close, 9.2 equal to 4.5. So the x is approaching 4.5 from the positive side. The 4.6 is slightly bigger than 4.5, which makes it approaching from the right side. So, all right, this is a number line. Here we have 9/2, which is the same thing as 4.5. If you're approaching the 4.5 on the right side, you are being bigger than 4.5, you can try 4.6, or even closer, like 4.55 or something. The 4.6 is easy. If you want to approach from the left side, you gotta be smaller than 4.5. That's why I'm trying 4.4. These are numbers for left limit and right limit. We're trying to just to get the idea whether it's positive or negative. And you can see if you using the 4.6, the number is, see the calculation. The numerator was 33 times 4.6 divided by 9 minus 2 times this. So the first one, we're getting negative 759. So it's a pretty large number. So I think the first one is negative infinity. The second one, we plug in 4.4, I think is positive infinity, which is just the infinity. Okay, that's to try a number that's really close to the limit value, what allows you to get positive or negative calculation. But you certainly have to guarantee your calculation was right. You can also graph the function, of course, that takes time, so right now. So this, the first one is negative infinity. The one is, right or wrong. Yeah. Negative infinity, and this is this question. Graphically is also fine. If you want to use graph to answer the question, saying many graph of function tend to give you some idea of how the function behave. So I think graphing many function is not wasting time. It's actually giving you more experience understanding the graph. But assuming that you do look at each graph to figure out the answer. This is number 3.
I have a question.
Yes.
Could you look at mine?
Okay, sure.
Because mine's different.
Yeah. 3 over 8 is 0.675. Yeah, to be less than 375, you can try 0.3. Plug in 0.3 and see if it's positive or negative. To be bigger than 0.375, you can try 0.4. Try 0.4 and try 0.3. Then you can see whether it's positive or negative. This is the only thing that's important is the sign. What you use infinity anyway. Just need to know, is it positive infinity or the negative? All right, so you can see the first two questions all involve some kind of polynomial, the numerator degree 1, the denominator degree 1. So there's only one virtual essence that we're calculating. Question number 4 is different. It has a trig function. If you're a little bit unfamiliar with trig function, now it's time that you have to pause a little to think about how we handle this kind of question. If you're not very familiar with cotangent function, one of the techniques is to convert it to sine or cosine. And do you know what was the relation with cotangent?
Cosine over sine.
Cosine over sine, yes. So essentially, the cotangent function do involve a little bit of division. That's why cotangent function could be undefined at some of the points. So here we are. Let's see. All right, so again, the technique still, you can try calculating it. I believe you do, this cotangent function is a division, so this is actually cotangent of 3x. The fundamental relation to the two most basic function is sine and cosine. All the other trig function can be related back to sine and cosine. If you're not sure, we'll convert it to sine and cosine. So this is a cosine 3x divided by sine 3x. So we're going to convert it to division between two functions. So then realize that whenever the denominator equals 0, it will be undefined. We will have a division by 0. Whenever we have division by 0, we have virtual essence. That's the case here. If x equals pi over 3, then 3x is pi over 3 times 3. That was pi. Sine pi equals 0. So that limit for the x, the value pi over 3, is causing the denominator equal to 0. It is undefined point. It is a virtual essence. So we need to know how to calculate it. Another thing is we don't have cotangent function in our calculator. Even if you want to try to use numerical calculation with a calculator, we won't be able to do it since we don't have cotangent function. So we can convert it to cosine and sine, and then we can use our calculator to do the computation. So realize if you are trying to do pi over 3, the number itself is, we don't see infinity, no, that's an asymptote because the number equal to 0. So now we need to know whether it's positive infinity or negative infinity. Now pi over 3, you can use your calculator to calculate its rough value. Pi over 3 is a 1.047. So to approach pi over 3 from the negative side, that was negative, you got something, this is a pi over 3. Drawing it on the number line, which is roughly 1.047. So roughly 1.047. So if you were to approach it from the negative side, from the left side, you want to use any number that's slightly smaller than pi over 3. Right now, a good number to use will be 1. You make x equal to 1, and that's not equal to pi over, not equal to 1.07, but it's pretty close. So you can plug in the number to see whether it's positive or negative. I'm assuming that probably is going to be a pretty large number. So then I'm going to get x equal to 3 to the calculation. So you're going to go cosine 3 times 1, which is just 3. Right? The denominator is sine 3. As a rule, whenever you use your calculation to calculator to do this kind of calculation, make sure your calculation is the radian measure. If your calculator have automatically set in degree measure, then you gotta change the mode of your calculator. If you are using the wrong mode, the answer is completely different. So make sure calculator is in radian mode, calculate cosine 3 over sine 3. What do you have?
Negative infinity.
Negative infinity.
No, negative square root.
So it's a really negative number, right? So, I can see, on my side, let's calculate cosine 3. You can calculate this with your calculator. Cosine 3 divided by sine 3, the number is pretty, is that what you have? Negative 7 point?
Yeah.
Negative 7 point. Right, so this is roughly negative 7.015. So we know it's for sure it's a negative number. That's not very close yet. I mean, it's less than 5. So we know that was negative infinity. Let's see if this works. Okay, so that's how it looks like. You can also see how it is on the graph, but of course we don't have the help of the graph if we're doing that test question. So we'll make sure we're able to do those. So cotangent 3x, that's how it looks like. I'm gonna zoom into the pi over 3. So you already kind of know the pi over 3. Pi over 3 is roughly 1.1, like around 1, right? 1.047. We're looking at the left, so there's plus negative infinity on the left of pi over 4. Pi over 3. On the right is positive infinity, on the left is negative infinity. So cotangent functions do have a lot of asymptotes. So we're looking at one of them, the asymptotes. This is how you identify the limit from the graph. But so when you look at the question number 1, you have to know this is the asymptotes. And the way we can do it is you can calculate cosine 3 times pi over 2, that would just cosine pi. So if you're using your calculator, calculate cosine pi over sine pi, that's going to be a domain error. So the calculator won't be able to do it. So we kind of know from there that, hey, we got an asymptote here. That was undefined. Therefore, we know that there must be an infinity as a limit, and we just need to know if it's positive infinity or negative infinity. That's question 4. All right, one more example on trig. All right, so this is a number 5, and let's see what is the limit. And we do have a sine function. The x is approaching 0. This. I think it's undefined. X is approaching 0. Let's think of it logically. If x is approaching 0, see there's no side, left side or right side. That kind of made it a little hard to do. So let's see if x approaches 0 from the positive side. Then 9 over x will be approaching positive infinity. And then sine of 9 over x will be like calculating the limit of the sine of infinity. And that we do not have it. When you want to calculate sine of a really large number, and you can calculate multiple, you try sine 1000, sine 2000, sine 3000. None of them are approaching any particular number. This is going to provide you a big oscillation. So around the 0, the sine function, kind of a reciprocal function, actually goes to a lot of up and down. So sine of infinity does not have a limit. This one does not have a limit. So it really answered the yeah, it oscillates. That's why there's no limit. If you look at the behavior of the function, I think it's because sine of infinity does not exist. So that's what happened around the sine function right in the middle. So we want to know at 0 what was the limit. X is approaching 0, but then you can see from the left or from the right, there was curve, and then the curve's frequency increased so much. to the point that we won't be able to differentiate anymore. So there's no limit. You can see the limit is between -1 to +1, but then it doesn't go to any particular number. We cannot use an interval as the limit value. As far as the limit goes, we are only allowed to use a single number as the limit value. If we were allowed to use a range of numbers as the answer, it would be -1 to +1 anywhere. This question, and we see this kind of limit before when the limit does not exist because of the fluctuation of the function. All right, another example with the limit is does not exist or goes to infinity is logarithm function. And let's see. I guess I'll just use a graph, or you can use a number. So let's see. Question number 6. X is approaching 8 from the positive side. So we can try x equal to, x is approaching 8 from the positive side, meaning x got to be bigger than 8. So we can try x equal to 8.1. Okay, 8.1. And then you can see what's the number, x equal to ln of 8.1 minus 8. To calculate this is going to be logarithm of 0.1. And that should be negative. So this is going to be negative ln of 0.1. Negative 2.3. Okay, that's for x equal to 8.1. We're making x approaching 8. So I can try again to use the number to illustrate the point. Negative 8 points, approaching 8 from the positive side, bigger than 8, so 8.01. We're getting closer. So the function value is ln of 8.1, 8.01 minus 8. So after the subtraction, we have 0.01, ln of 0.01, and then that means this is going to be actual 0. Negative 4.6. We can make it even closer, 8.001, 8.001. So let's make it small. Right? I'm adding a couple of zeros and see what it's. Right. So you can see it's getting more and more negative, but it's getting to a negative in a really slow fashion. Negative 20, and then I'm adding more zero there. All right. Guess what's the limit?
Negative infinity.
Right, negative infinity. We can add more zero. Logarithm is funny. Ln function is getting bigger and bigger, but it's not that fast. So
Yeah, it's logarithm.
right, logarithmic. It's even slower than a polynomial or a linear function. So it's really slow change, but changing in that direction anyway. So we would say negative I. So that's the result I can get from entering number that is approaching 8 from the right side of 8. Approaching 8 from the positive side, you got to try a different number that is bigger than 8, but is getting closer and closer to 8, just to see the tendency. Let's use number. You can also use graph. Graph of ln x minus a look like this. Logarithm function. Let's see. Right, so this is a graph of it. Right, you can see I tried 8.1, just like here, and then 8. But you see the whole function once you try it, getting even more closer, the function went all the way down. So it's negative infinity. So then at 8, we do have a vertical asymptote. The function is decreasing to infinity. This is how we can identify the limit using the graph. And logically, it's a little hard to differentiate, to explain. So you have Lx approaching 8. So x minus 8, which is that calculation, would be approaching 0 from the positive side. Okay, so then ln of x minus 8 would approaching ln of 0 from the positive side. That part is a little hard to explain. This value actually has a limit of negative. And the good explanation for the ln of 0 might be the graph itself. Hard to see that. Ln of 0 is undefined, but ln of any small positive number is valid number, but they're all negative. Logarithm stop at e. Ln of e is 1. Ln of 1 is 0. So anything lower than 1 ends up giving you a value that's negative. On the number to the 0 side of the logarithm is negative. It's negative. And that's this example. Question or right? Any questions so far? I want you guys to start trying it yourself to see if it helps. This one is a piecewise defined function. You'll be calculating the limit on the left side of 3, on the right of the 3. Because we got 2 different formula, you will be following the formula for the computation. So these are more or less a exercise for calculating the limit using the 2 different formulas. Like the first one, x is approaching 3 from the negative side. So we use the first formula, that would be -9 divided by, this is -3 plus 3. Oh, it's -9 divided by 0. But it's approaching 0 from the negative side, so it seems the denominator is negative. Numerator is negative, so it's positive infinity. Okay, and then the other side is opposite. I guess it's a negative infinity. Okay, and then because of the two-sided limit, well, this one I was supposed to use this formula, right? X is bigger than 3, so we would use it 2 times 3. So that's going to be 2 times -3 plus 10. So the piecewise defined function at different side of the x, different left side and right side of -3, you have to use different formula. The first one is left one limit, so you use the first one, x is less than -3. That is what's causing it to be negative infinity. And the second one, we have to approaching negative from the positive. We're not using that formula anymore, we're using this one. So we have to follow the second equation using x equals negative. And that's 2 times -3 plus 10 actually equal to +4. And then obviously the 2 are not equal, therefore the limit is not equal. Decided question. Decided question. Had it wrong. Negative.
It's not good.
Graphic?
I think I tried to positive infinity, I tried negative, they're both wrong, but they were supposed to be. Okay, let me graph it. It's weird.
Mine have different numbers, but mine for the first one was do not exist.
Yeah,
Okay,
I don't know how.
I think the computer is being weird.
So that'll be -3 plus 3, which is 0.
Yeah, that's why.
So it has to be less than 3.
Okay.
Well, the reason it is less than 3.
But it's not a two-sided limit.
Like this is that one, and then we will make x less than -3, so x is less than -3, that's this part. Okay, and then the other part is y equal to 2x plus 10. And then x is bigger than -3. So it's definitely discontinuous. But I see this side is infinity, right? I had infinity already, but I think it's it should be infinity, if you look at the graph. This side should be plus, what is it, a 4. Okay.
Yeah, mine did the same thing. I think it's just wrong, honestly.
Yeah, I think the answer key was wrong. I think it should be infinity on the first question. Oh, you might
Yeah,
have.
because the reason it's not D and E is because if you distribute out the negative sign in the front, it gets rid of the -3, so it's 3 plus 3.
Right.
So making the denominator 6, not 0. Okay.
No, it's because it's a left-sided line.
Yeah. So we put that one into two-sided limit.
Okay.
Yeah, if it's two-sided limit, it would be a DA. I think if it's left-sided limit, it should be infinity. I will accept it if you write DAE or infinity, but what word, I think the grading coded as DAE. I think you might have exactly the same situation like my version. So the first question, you should answer DAE. Second is a calculation using the second formula, DAE, because the two is not the grade. Yeah. Number 7. Okay. This is only this. Three times negative 1 is negative 3. Wait, this is a 1. This is 1. Second one. Second one is that one. This is the left, so it should be G. Yes, I tried. Any other question? What is your question number 7? The first one, I really think it should be infinity, but the accepted answer was D and E. Any other question? I'll leave it this, and let me try to go over section 6 to see if I left anything yesterday. We started talking about it yesterday, but no. Let's look at the remaining example in sections. Okay, so in this section, basically talking about any limit that may involve infinity. You may have x approaching a number, the whole function itself approaching infinity, or you may have x approaching infinity, the whole function is approaching a finite number. In either cases, they are considered limits that involve infinity. When you have a limit that involves infinity, we define vertical asymptote and horizontal asymptote. Whenever the y value approaching infinity, we consider that being a vertical asymptote. Whenever they keep calculating vertical asymptote involved, try to figure out the number that makes the y value go to infinity. And if you go to division, your function construction, you will make the denominator 0 to determine the asymptote or the number that causes the function to go to infinity. Like this question, you will let the x squared minus 4 equals 0. Then you solve 2 and negative 2. So 2 and negative 2 are two lines, vertical line, that has that asymptotes. They're the function asymptote. Asymptotes are not part of the graph. They are like invisible line that separate the graph. So the actual function graph does not involve this line, but having that line there helps to see the relation in the. Okay, this is another example that we do not have limit of infinity. We do not have an asymptote because x squared divided by x minus 1. We had that division before. X squared minus 1 divided by x minus 1. The answer is x plus 1. So they actually have very similar behavior to a straight line. This function is a straight line with one single point removed. So this function does not have asymptote. That means whenever your numerator and denominator have a common factor, in this case, the common factor will be x minus 1. You should cancel all the common factor, therefore there's no longer asymptote. So we're gonna define a term that's called an indeterminate case. All right, what's an indeterminate case? That's dependent on a calculation that causes us not being able to substitute the x value to calculate it, and we have to use other ways for the limit calculation. For example, if you make x equal to 0, then sine 0 over 0 will be undefined. It's 0 divided by 0. This one also, if x equal to 1, numerator equal to 0, denominator equal to 0, that's 0 divided by 0. Whenever 0 divided by 0 happens, we do not say the limit does not exist. We will say that this is an indeterminate case, in the indeterminate form, meaning that we gotta find other ways to determine the limit. We mean that this is indeterminate. We cannot determine using the calculation. We'll have to try other ways. We can try numbers, say x is approaching 0, so makes x equal 0.1, 0.001. Try numbers, try graphing, try use other method. So determining with alternative methods the definition. Right. Horizontal asymptote is when x approaching infinity or negative infinity and function somehow approaching a finite number. That finite number is a y value that function approaching to. So it's a y value that we try to find. It is a horizontal line that we're trying to find. And the function is approaching to. So it's really the any asymptote is a limit process or limit idea. Visually, it's looking like the curve is approaching a line. That's what we are calling it asymptote. Any question? It's kind of like the name horizontal asymptote is a horizontal line, y equal to value of that line. A vertical asymptote is a vertical line, therefore we have x equal to a number. Whenever x equal to a number causes a function to be undefined or causes a y goes to infinity, that's a vertical asymptote. Whenever x equal to a number causes a x value to go to infinity, that's a vertical asymptote. Let's see how do we determine horizontal asymptote. The only reason that horizontal asymptote exists is because the limit of x goes to infinity. Okay. So the definition itself is telling us how do we determine horizontal asymptote. That is, you make x large, you make x goes to infinity. So if we want to determine the horizontal asymptote of this function, we will make x goes to infinity. So we would just say over here. One thing is you can graph it, and once you graph it, you can see the left and right where does it goes to. Or we will try to look at the limit. Say limit of a function x squared over x squared plus 4. You want to see the value of the function when x goes to infinity. This value is the asymptote. So we're going to calculate what it is. If x goes to infinity, what is this value? Let's try a number. X goes to infinity, the meaning of it is x is arbitrarily large. So we can make x equal to 1,000, right? If x equal to 1,000, that's pretty large already. So you have the numerator is 1,000 squared. And the denominator is 1,000 squared plus 4. See that whole thing? The numerator is a million, right? The denominator is a million plus 4. So what will be the answer? Almost 1, right? This is almost 1. So answer to the limit actually equal to 1. The reason for that is because the x goes to infinity. X is really large. So x squared is really large. This x squared is also really large. So what happened to that 4? 4 is compared to that infinity number, compared to x squared, 4 is really, really small, right? Almost negligible. So the ratio between the numerator and denominator, when you try to compare the number, the denominator is slightly bigger than the numerator, but it's not that big, right? It's bigger, than the x squared, but it's bigger by just 4 little numbers. So and the power is really important. A function that has a higher power will ultimately become a lot larger. So another way to calculate this limit is look at the behavior of the polynomial. But to calculate this limit quickly, we'll focus on the one that has higher power. So this limit actually equals the limit of x squared divided by x squared. Normally with infinity, when x goes to infinity, we only care about the one that has the highest power, because the one that has lower power, like this one, has power 0 degrees. It doesn't really affect the limit. So this is really equal to 1, because x squared over x squared equal to 1. So then one of the rules for calculating limit when x goes to infinity is compare the power. Another way to look at it. This is more or less a analytical way to look at the limit, and this is use a number to represent a limit. Another way, of course, is to graph it and see on the far right what's the behavior. This function has a horizontal asymptote of y equal to 1. That's the asymptote. And question number 6. All right, let's talk about some of the pattern that we observe. From this example, you can see that the degree of the polynomial is really important. Suppose you have a polynomial in the numerator, you got another polynomial in the denominator. This is the abstract way to say that we got a polynomial. It looks really long, but all that means is you got one polynomial over another polynomial, and then you look at the degree. Each polynomial has a multiple power function. We put the high power in the front. We consider that power as the degree of the polynomial. So the degree of the polynomial will really affect the limit. If the numerator and denominator have the same degree, like the one that we already had in this example, the x squared over x squared, we have the same degree, so the horizontal asymptote is x squared over x squared, which equals 1. So 1 will be a horizontal asymptote, right? So first case, if the numerator and denominator have the same degree, their horizontal asymptote would be that coefficient. So you take that one over this one. The power is the same, you get it canceled. Again, all the other one doesn't matter anymore. Because in the end, when x is approaching infinity, all the one that has small power is relatively small compared to the one that has high power. We only want to compare the one that's largest because we're looking at behavior at infinity. Second scenario is when the numerator have a smaller power. If the numerator have a smaller degree than the denominator, if n is less than n, that means the numerator is much smaller than the denominator. That is like dividing a small number by a much bigger number. So if you're dividing a small number by a super large number, the whole fraction, the whole division goes to 0. So the limit of the function when x goes to infinity would be 0. That is when the numerator has a smaller degree. Remember, when x goes to infinity, a smaller degree means smaller number, and therefore that causes a change at infinity. Last one, if the numerator has a higher degree than the denominator, that means the numerator is much bigger than the denominator, right? If you have a really large number divided by a much smaller number, then the answer of the division will be a big number. So the limit of the function actually goes to infinity, actually. Positive infinity or negative infinity, depending on the an and bn. Therefore, we do not have asymptotes because it's not approaching any finite number. So in the last case, with the numerator have a higher degree, there is no asymptotes because the limit of the function would goes to infinity. Any questions? So this is giving us a systematic way to determine the horizontal asymptotes. For example, this one. So if we want to know the limit of this function, we would look at the degree. Right? So what's the degree? The limit of x over root of x squared plus 1. You might find the limit difficult to calculate, but think about the highest degree. The numerator degree for 1, there's only one term, there's nothing to change, but only when x approaches infinity, what only matters is one that has higher degree, the one that has a lower degree can be disregarded. So we're calculating x over root of x squared. Okay. So we're okay there. So I'm forgetting about that plus one because x is approaching infinity. If I calculate other things, so I would not ignore that plus one. But as long as x goes to infinity, then that plus one it has no effect on the final answer. So with this one, if x goes to infinity, x is a positive large number, like 1,000. So 1,000 squared root of 1,000 squared, the numerator and denominator actually is the same thing because root of x squared is x. The square root will cancel the square. So this is actually equal to the limit of x over x. That was positive. And this is actually equal to 1. The other one is when x goes to negative infinity, root of x squared plus 1. If x goes to negative infinity, again, that's the infinity, means x is really large, but negative. This is equal to the limit of x over root of x squared. X goes to negative infinity. See what happened here? The numerator is a negative positive number, so negative large number. So let's try negative 1,000. Right? So this will be negative 1,000 in the numerator, but it will be root of negative 1,000 squared in the denominator. So the denominator actually, because of the root sign, is positive number, right? The square will cancel the square root. That will be positive after you square it. Okay there. So the numerator, this is a negative 1,000. This is a positive 1,000. Actually, you take people want this. Negative, sorry. It's negative 1. Because in this situation, the numerator is a negative number, the denominator is a positive number, so the whole division has to be a negative number. Any questions? This might be the last example. As also we're out of time. We can try graphing this to get a better understanding of it. So you can see why it is going to two different directions. That is square root of x squared plus 1. So that's the behavior. The function is approaching 1 on this side, but it's approaching negative 1 on the other side. So on the left, negative infinity is negative 1. On the far right, it's approaching positive 1. And that should be it for today. Let's try to finish most of the 1.6 homework. We'll come back tomorrow if you have questions.
Are there any questions about vertic velocity codes? Couple of times on me.
These are the one numbers. We have 1.7. Right now it's 1.6.
Yeah. Oh, no.
There's a question, reading question on the homework.
Yeah. Yeah, there's one. Yeah, that's the only one.
Yeah. The answer should be no. The graph is not correct. Yes, this is from section 1.4. What is it asking? To find the limit using the formula. So if x is approaching 1 from the negative, that was positive side, you would use the second formula, you use this formula.
One of the questions here is because you don't know which one it is, you don't know if you're getting further away or closer to the right answer.
So the x is approaching 1, so it becomes 1 plus 1 and
But you probably already changed the other.
Yeah.
So I just have to do-
But it's like,
so that will be 7 times negative 1. Negative 7 minus 2n. So you have negative 7,
spell this
so we
out.
don't.
That was my class.
No, you would set this equally if you get this. So we're
Pretty much,
trying
I'm
to
coming
make
around
it.
1.6.
Yes,
Oh. Happy 8. See you tomorrow. You.
Oh, I have a question about, one of these, because there's like a bunch of kinds of these. And like there was some on section 4 and now there's one on section 6.
Uh-huh.
And I just in general don't really like. So from here I know, so two from the left, so I go to X is 2, and then from the left, but there's no such thing as like obviously infinity because it stops right there. So.
So the
from
limit is, left limit, that's 3. So the left side is 3.
Okay, so, okay.
And that one was right side was -2.
Okay.
And this is,
G of X is just 2.
it's C and E, this is a 2-sided. Because,
Oh, because since there's multiple, it's being.
right,
Okay,
right,
okay.
whenever the left side does not agree with the right side. it's E.
Okay. So then, so whenever it's asking for 2, so 2 right here is in the left side. So this is the equation that's on the left side, so I go to the highest point of this.
Mhm.
Okay, that makes sense, okay. Then this one at 0, I have 4. Or is that, there's 2, so it's D and E.
Yes.
Okay. And then plug in 2,
Yeah, that would be the point, that's correct.
that's 2, so it'd just be 2 and 2.
Mhm.
Okay, thank you.
Try the rest, if you still have questions, we can look at it together.
Okay, yes, ma'am.